Hello students, welcome back. In this video, we're going to introduce our mechanic expansion for Nova Strike. Right now, we have our Nova Fleet Commander, we have our Alien Swarm, and they can fire bullets at each other, but no damage is dealt, right? We don't have a damage system in place. And so in this video, we're going to take those systems of our aliens, our player, our bullets, our bombs, and we're going to implement over top of it some type of damage system. So this is going to make our game actually finally feel playable. So let's head to the computer screen and we'll dive right into our lesson. So in this video, I've got Lesson 7 starter file, our mechanic expansion on damage systems, open here in vscode.dev. But I'm going to minimize my browser tab right now because I want to open that file directly. So I'm going to go to Nova Strike, Lesson 7, and Lesson 7 starter file. And here we have our playable game. So let's just see, can we deal any damage? Nothing. Nothing yet. Nothing. So our game is, not surprised, we're broken here. So we got to implement our damage system, because what we're going to have is when I hit an enemy, we're going to just blow it up immediately. It's going to die automatically. And when an enemy hits me, I'm going to lose some shield amount. I think we had like that shield per hit drain. I don't know. I think we set it to like 15 in a previous video. So let's take a look. Mission number 1 says we are going to set the damage system constants. Okay, so the systems that we need to set here, every time I hit an enemy, they're just going to die. We're going to remove them, but my score is going to go up. So I guess we're going to try to figure out how much do I want my score to go up by every time I destroy an enemy. And as I use bombs, right now, bombs are not a refillable we can't get any back. So what we're going to say is at a certain point, if you hit a certain score, we're going to reward you with an extra bomb. So those are going to be the two things that we sort of set up here for our system, because we don't really need to set anything for how much damage the enemy is going to take. They're just going to get destroyed. And we already know how much damage we're going to take because that's part of our shield system. So let's go look at those constants. And not surprised, where are we headed? For a new system, we're going to go to our student edit zone. So here we have all of our knobs, all of our dials for all of our different systems. Look, for our shield system, here it is, shield drain per hit. So we're going to take 15 damage when we get hit by an enemy bullet. But if I scroll down, here is our damage system constants. So we have enemy kill score and bomb reward score. All right, so every time I kill an enemy, how many points do I want to get? Well, I like 100's a nice number, so I'm just going to do 100 points. Every time we blow up an enemy, we'll get 100 points. And once our score hits what? I'll say 1,500, so 1,500 points. If I destroy 15 enemies, I am going to get a brand new bomb. And we'll make it so that this is reoccurring. So every time you score in 1,500 point intervals, you're going to get an extra bomb. Awesome. So there are our system constants. Let's scroll down and see what else we got here, though. In our color palette, no new colors in our color palette, so that's fine because we're just going to be dealing damage here. And what about our gameplay variables? Outside of our student edit zone, we now have, we have a score variable and a next bomb score variable. All right, so like if you think about it, when we start our game, we're going to say, hey, your next bomb is going to come at 1,500 points. And then once we hit 1,500, we'll say your next bomb is going to come at 3,000 points. And once we hit 3,000, we'll say, hey, your next bomb is going to come at 4,500 points. So we'll keep adding to this and keep track of when we deserve to get another bomb. All right, so now that we are aware of what values we have for our new damage system, let's go to mission number 2. And mission number 2 says, hey, you got to reset those. When it's game over and we start a brand new game, don't carry the score from the last game, right? If you earned, like, let's just say 6,000 points in a game and then you died, when you start the next game, you shouldn't start with 6,000 points. You should go back to 0. So we got to reset that score. And we're going to reset our bomb reward tracking. And this is going to set us up for a new game nicely. So our score variable that we just looked at, let's set it back to 0. And then that next bomb score, tab for autocomplete, we are going to set it, we don't want to set it to 0 because then that would give us a bomb right at the beginning when our score is 0. We're going to set it to that constant that we saw, bomb reward score, which is 1,500 points. So at the beginning of our game, our next bomb is going to come when we hit 1,500. Awesome. So mission 1, mission 2 in the books. that means it's time to move on to mission number 3. And mission number 3 is a big mission. It's super important for us to understand what is happening in this function called rectangles overlap. All right, so this function is taking in two things, object A and object B, and it's going to return an answer to a question. This question, this big question, which has 1, 2, 3, 4 lines, is going to determine whether or not those two objects that we passed in are overlapping. If objects are overlapping, that means a collision is occurred. Now, there's lots of different ways you can check for collisions. We are going to work with rectangular collisions. Why? Well, if you look, our ship is rectangle, our aliens are rectangle, and our bullets are rectangles. We made that design choice. So everything in our game is a nice little rectangle, and so we can use this function to check if two rectangles are overlapping. Maybe it's an enemy and a player bullet. Maybe it's our ship and an enemy bullet. Maybe it's our ship and an enemy ship. We can just pass those things in and check to see if the two rectangles are overlapping. Now, in order for us to understand what is happening here in this function, I think we need to go to the whiteboard. So let's go to the whiteboard, and I'm going to draw two rectangles. And these two rectangles could be anything in our game. We're just going to call them rectangle A and rectangle B. So let's see, I've got rectangle A. So here's rectangle A. Maybe I'll make this our player. This is like our player's ship. So here's rectangle A, all right? And we've got rectangle B. Yeah, sure, B. So let me think about this. I'm going to put B over here. Boop. So here's rectangle B. Actually, you know what? I think the way I wrote my code, I'm going to call this rectangle A, and I'll call this rectangle B. So there's A and there is B. Now, if we look, A has a couple of different sides to it, right? So we're gonna label this as line number 1. So line number 1, we're gonna look to see, how do we know if these two things are colliding? Well, A has a right side to it, a right side. And B has a left side, a left side. And right now they're not colliding because A's right side is not further along in the x direction than B's left side. See, in order for this collision to occur, something has to be true. We have to say, okay, A dot right, the right side of A, must be greater than the left side of B, B dot left. So that's our first condition that has to be true in order for us to have a collision. But let's see what happens. What if A, this object, moves over here and over here and over here, and now A is all the way over here. Well, here's A's right side. A's right side is definitely greater than B's left side. So this is true. But now we've gone too far. We've gone too far because A also has a left side and B has a right side. And what has to be true about this collision? Well, the left side has to be less than B's right side, right? We got to make sure that we're in this region. So we'll also say, okay, not only does this need to be true, that needs to be true, and A's left side needs to be less than B's right side. All right, so that's looking pretty good, but that's only for horizontal collisions. What about our vertical collisions? Well, what if we put my A up here? So now A is up here. There's no collision going on, but we could track A's bottom. So there's the bottom. And B has a top. And we got to move it so that the bottom of A is greater in its vertical position than the top of B. So we're going to say, okay, A dot bottom has to be greater than B dot top. So all of these things have to be true. And there's one last thing, because A could move down and down and down, and now A finds itself all the way down here. Well, now A went too far. It went too far. And so let's target the top of A and the bottom of B. And we know that A's top has got to be less than the bottom of B. So A dot top has got to be less than B dot bottom. Every single one of those conditions must be true in order for a collision to occur. If every single one of those is true, it means A is somewhere inside B, and a collision has occurred. So this is exactly what we want to do. Now, how do we get the left and the right? So ready, here's like A. So the left side is the X property. So this is our left side. This is just A dot X. How do we get the right side? Well, the right side is going to be the X property of our object plus the size of the object. So plus A dot size, because these are rectangles. So they have that size property that we set. And then right up here is our top. So our top is just going to be A dot Y, the Y property. And then how do we get the bottom? Well, the bottom, we're going to add that whole size again. So our bottom is going to be A dot Y, our top, plus A dot size. So there are our conditions for a collision. So let's take a look at what we have in our code. So in our code, we have 3 lines already written for us. Let's see if I can make that just a little bit smaller. All right. So in our code, we have object A's X is got it plus object A's size. So right there, that is the right side of A is got to be greater than the left side of B. So that's our first condition. Then we have the left side of A has got to be less than the right side of B. That's our second condition. And we have the bottom of A right here. So there's the bottom of A has got to be greater than the top of B. There's our third condition. We just have to write our fourth conditional check to make sure that there is a collision. So it's the top of A. It has to be less than the bottom of B. So the top of A, how do we get the top of object A? Well, object A dot Y, that is its top. Has to be less than the bottom of B. How do we get the bottom of B? Well, we take object B dot Y, which represents the top of object B, and we're going to add to it object B's size property. And with that, if all 4 of those questions answer yes, then what we'll return is a true statement. We'll return yes to this question. We'll return true. And now we have a way to check if any 2 rectangular objects are overlapping or colliding in our game. Perfect. So now let's go see how we can use this brand new function. In mission 4, we find ourselves in the check player bullet enemy collisions function. All right. So we loop through one of our containers. We're looping through our player bullets container, and we're looping backwards through the array, probably because we're going to want to remove a bullet. If our bullet collides with an enemy, right? If our bullet collides with this enemy right here, boom, it keeps moving. I don't want that to happen. Once it collides, I'm going to want to remove the bullet and remove the enemy. So we're looping backwards through that array, and we're grabbing a bullet. Then we're looping backwards through the enemies array, and we're grabbing an enemy. So I have a singular bullet, and I am now going to check if that singular bullet has collided with any of my enemies. And then on the next loop, we're going to check, hey, I get a different bullet. Let's check to see if that different bullet collided with any of my enemies. And we're asking a question. We're saying if, and then we call our rectangles overlap function that we just looked at. And object A is a bullet. Object B is an enemy. And if those 2 things overlap, that function returns to us an answer to a question. It returns yes, true, or no, false. Well, if it says yes, then we have overlap. It means my bullet has hit an enemy. So what do I now want to do? I want to destroy the enemy and the bullet. All right, so let's destroy the bullet first. So player bullets is the name of the container or array that is holding all of our player bullet objects. And to remove something from it, we will call .splice. Now, we got to specify the position that we want to remove at. We are going to remove at position I. You can see right here, we grabbed the bullet at position I. So I. And we only want to remove one of them. Semicolon. Good JavaScript. So that's going to get rid of our bullets, but we also want to get rid of our enemies. So we're going to now target our enemies container, our enemies array, enemies.splice. And here we're not going to pass in I because if you look, we used a variable j to loop through our enemies. So we grabbed the enemy at index j right here. So at index j. So we're going to remove that enemy at index j, and we only want to remove not 12 of them. We only want to remove one of them. That was a typo on my part. And then the last thing we want to do is, this is the most important part, we just destroyed an enemy. So it's time for our score to go up. So we're going to increase our score variable by the constant that we set, enemy kill score. I think we had it to 100 points because 100 is a really nice number. Perfect. And then if you look later on, we call something called check bomb reward. So we destroyed an enemy, our score went up, and then we're going to call this function check bomb reward and then break out of this loop. So we'll probably look at check bomb reward later in another mission. But let's just see, can I destroy an enemy now? Boom. And my score went up. Hey, I scored 100 points. New high score. New high score. Oh, I missed that. Don't get out of here. I missed them. There we go. So already this game is feeling much more alive. The fact that I can destroy our enemies. So that's really good. Of course, I can't take damage. So this is really nice. Hey, I can collide with them. That's kind of cool. So we can destroy them on collisions. So that's kind of working. But I probably should take damage. I should probably start taking damage. Let's go look at what mission 5 has. So our collision system between our bullets and the enemy is working nice. Now we got to give the enemy that same luxury. So mission 5 finds us in check enemy bullet player collision. So we're going to do something really similar here. We're going to loop through all of the enemy's bullets. And we're looping backwards because if a bullet collides with us, we are going to remove it from that array. We're going to get it out of there. And then we're checking. Okay, we grab a bullet from our array, and then we're passing it into our rectangles overlap. We say, hey, that enemy bullet that we just grabbed, does it overlap with our player object? And that's going to give us an answer to a question. It's going to say yes or no, true or false. And if the answer to that question was yes, true, we're going to run this code. We remove the enemy bullet. Perfect. But now we got to take some damage. So our shield needs to decrease. It's got to go down. So we're going to take some damage. Right now we're taking 0 damage, which is OP. It's overpowerful. We got to nerf the player. And so what we're going to do is we are going to actually remove it by taking shield drain per hit. That was the constant that we set in our shield system. It's 15 damage units. But when we subtract from it, there's a chance it could go negative. Like if I only had like 5 shield points, if I subtract 15, my shield will be at -10. I don't like that. I want to cap it down at 0. So I'm going to take shield and I'm going to constrain it. And I'll constrain the shield value between 0 and max shield. We'll make sure it doesn't go above or below where we need it to go. And with that, I now can take damage. I'm not happy about it. I no longer feel like I can take on anything. Let's just see. Yep, there is the damage. So if I take enough damage, will I die? Let's see. Damage. Hit me. Damage. Hit me. Damage. A couple more. Let's see. All right. Probably got 2 more shots left in me. There's 1. All right. And, oh, come on. It's so hard to take the damage. There we go. All right, perfect. So my shield depleted fully, and we have game over. And that makes sense, because if you look at our next line, we have a check. It says if the shield is less than or equal to 0, means we are going to set our current game mode to lose. That ends our game, shows our lose overlay. Mission 5 is complete. What's mission 6 have us do? Mission 6 has us check our enemy player collisions. So an enemy ship can collide directly with us. And when that happens, we saw that we're removing the enemy, right? That happened already. I'm pretty sure we saw that. Let's just see, right? So I can fly right into this enemy and remove them. But when I remove them, I got to take damage. So right now that damage system is not working. So we loop through our array of enemies backwards because we're going to remove the enemy when we collide, and we grab a specific enemy at index I. And then we ask a question. We go to our rectangles overlap function. We say, hey, does that particular enemy and does our player object overlap? And it will give us back an answer to that question, yes or no, true or false. And if the answer is true, this code is going to run. Well, we remove the given enemy from the array, and now we got to take damage. And this is very similar to what we did before. Our shield is currently being reduced by 0. We don't want that. Let's reduce it by shield. Oh, you got to spell shield right. Shield drain per hit. That could bring us into the negative. So let's constrain our shield value. Shield is equal to constrain. The value that we want to constrain is shield between 0 and max shield. Perfect. And then let's just verify. If our shield is less than or equal to 0, we are going to lose. So we could lose here on this collision. Now we are even weaker. We can take damage from bullets. We can take damage from enemies colliding right into us. And there is that damage. So goodbye, OP Nova Strike Commander. You now actually have to fight and play the game. You are off, super easy mode. Super easy mode has been removed. Well, we got 2 more missions. Let's see what else we can do here. Ooh, mission 7 is going to give a little bit of power back to the player because this is going to be in our check bomb collisions method or check bomb collisions function. Right now, I can deal damage via my laser bullets. Boom, boom, boom. That's me firing. Boom, boom, boom. But I cannot deal damage. Do I deal damage with my bomb? Nope. It just makes a nice little pink circle that the ships can fly through. Well, I want to make it so that if a ship or a bullet flies through a bomb, they are going to take damage. They're going to be destroyed. And so if we look here, we are looping. Well, the first thing we do here when we call check bomb collisions is we check, is there an active bomb? If active bomb is equal to null, there's no bomb, we just return out of this function. Get out of here. If there's no bomb, there's no way there's going to be a bomb collision. But if we don't do this, we loop through all of our enemies going backwards because we're going to want to remove enemies from the array if they are inside of our bomb. So we grab a specific enemy and we call a function rect center inside bomb and we pass in that enemy. So let's go look at this function really quick. Rect center inside bomb. I think it is probably up. Let's just check. If I go up, yep, it's right up here. Rect center inside bomb. And what this function does for us is it gets the center of the rect, so it's x coordinate and it's y coordinate, and then it does some neat little math right here. So we calculate something called a dx value and a dy value by getting the difference in the x position between our rect, so maybe like a ship, and our bomb, the y value of our ship and our bomb. And then we do some really, really cool math for the Pythagorean theorem. So let's actually just go look at this math here for 1 second. So right here, imagine here is my bomb. Okay, here's my bomb's radius. Zoop. Perfect. All right. And here is my ship. And here is their center. So we want to determine, is this rectangle, is our ship inside the bomb radius? How do we figure that out? Well, all we got to do is just look at how close they are. So we got to say like, okay, there's a line that exists between those 2 points. We'll call that, I don't know, what do you want to call that? Well, we'll just call it like the length, all right? It's the length between them. And that line can be thought of having 2 parts, a horizontal part, which is a representation of how far away these centers are in the x direction. I'll call it dx. And a vertical part, how far away they are in the y direction. I'll call that dy. And so there's a really nice relationship in trigonometry for right triangles called the Pythagorean theorem. If I refer to this side as A and this side as B and this longest side of our triangle as C, the Pythagorean theorem says, hey, if you take A and square it and add B squared, you get C squared. So the distance away from these 2 centers can be found as taking dx and square it, adding dy and squaring it, and you'll get that length squared. Now, you might say, okay, I don't want to solve for this squared though. I want to just solve for how far they actually are away. So you just take the square root of both sides and you get that the length, the distance between those 2 points is the square root of dx squared plus dy squared. Now, as our rectangle moves closer and closer, that distance is going to get smaller and smaller. So right here, that distance got smaller. Right here, that distance got smaller. But have they overlapped yet? And the answer is no, they have not. They overlap once that center point is on the radius or less than the radius of the bomb. So our hit condition, our condition for a hit, is going to be if that length is less than or equal to the bomb's radius. So we'll say bomb radius. So let's just see. So I can say, okay, the length is the square root of dx squared plus dy squared. If that is less than or equal to the bomb radius, then we have a hit. Means we've destroyed some ships. But it's quirky. We don't really like taking the square root of things if we don't have to. And so here we're taking a square root. We can get rid of it by squaring this side and squaring this side. And so here is our final check. Dx squared plus dy squared. If that is less than our bomb's radius squared, we have a collision. It means there was a ship inside of our bomb radius, or maybe a bullet, either one. So that is our collision check here, and let's go see how it's implemented. So you can see here we calculate dx by subtracting the x values, dy by subtracting the y values, and then we have that check. If the distance between them is less than, the distance between them squared is less than the bomb's radius squared, we return an answer to this question. That question is either going to be true or false. So we're returning it back to mission 7. So if it was returned and it says true, yes, the ship was inside of our bomb radius. And so now we can do some positive things for our player. And let's do some positive things. What do we want to do? It says destroy enemies when they're inside the bomb radius, remove effective enemies, and increase the score. All right, so let's increase the score here. We're going to increase the score not by 0. That would be a bummer. Let's increase it by enemy kill score. I'll go all the way down here and do a tab for autocomplete. But then I need to destroy the enemy. So let's do enemies dot splice. We're going to target our container, our array holding every enemy, and we're going to remove the enemy that is at our current index of I. And I only want to remove one of them. All right, let's test this out. If you notice, before we test this out, we then check our bomb reward score because we just earned some points. So we've seen this now twice. Every time we earn points, we're calling check bomb reward. So we're probably going to go to that in mission 8. But before we get out of there, once we're done doing this for all of the enemies, right? This is for all of our enemies, removing them if they are in our bomb radius. We then remove the enemy bullets if they are in the bomb radius. So we call that exact same function. And if it returns true, we remove a bullet. All right, let's check it. Is our bomb going to protect us now? So let's put some enemies in here. Boom. And they get wiped out. Perfect. Feels powerful. But I'm out of bombs now. Oh no, that power went right to my head, and now I've used it all, so now I must rely on my laser gun. Well, in mission number 8, we're going to get the ability to get some of those bombs back. So let's take a look at it. Mission 8. Mission 8 is that check bomb reward function. We've seen that we call this anytime we earn points. And so we ask a question here. It says, if our score, if the current value of our score is greater than next bomb score. Do you remember we set this at the start of our game to be our constant of 1,500 points. So if we score 1,500 points, it is time to reward our player with a brand new bomb. And so there is a variable. Let's just go look at our gameplay variables. So I'll jump. You can stay here. In our gameplay variables, we have the bomb count variable. So right now, my bomb count is 0, but when I restart my game, my bomb count gets set to 3. We're going to add 1 to the bomb count. And then we just got to change the next bomb score to make sure we get our next bomb at the right time. So I'm going to say bomb count. There's our bomb count variable, and we're going to increase it by 1. We can do that with plus plus. Plus plus means just add 1 to it. So watch what happens if we just do plus plus. And I'm going to run the game. All right. Can I get 15 points quick? 1,500 points? I bet I can do it pretty quick. I'll pause the game, or I'll pause the video so you don't have to watch me play. Okay, so I'm at 1,400 points. I'm about to hit 1,500. What happens? Hey, I got a bomb, and I got another bomb, and I got another bomb. I just keep getting bombs every single time. And that's because we've never, I mean, this is kind of nice. Now I can just use my bombs as much as I want. But we don't want that behavior. And the reason why this is happening is because we never then change the next bomb score target. So right now we just increase our bomb count and our score is always going to be greater than 1,500. Every time we score points, we just get another bomb. That's not the right behavior. So our next bomb score variable, I am going to add to it the bomb reward score. So when it started at 1,500, then when we get it, we're going to make it 3,000. And then when we get it again, we'll add another 1,500 to be 4,500. And so now this should work. This should work better. And one of the ways we can check is, let's go back up to mission 1. That way we don't have to play through this. Let's put our bomb reward score at, say, 200 points for right now. All right, we'll set it to 200. So now if I kill 2 aliens, I should get a bomb. All right, so there's 2, and I got a bomb. Now on this one, I should not get a bomb. Perfect. But at 400, I should get a bomb. Perfect. And at 600, I should get a bomb. So nothing there. And I got another bomb. So this is now working in the intervals that we want. Let's change that back to 1,500. And I think our damage system is complete. I think we are all set here. Let's just see. Let's verify that everything is working. So I can damage the enemies. The enemies can damage me. I can launch a bomb, and I can remove enemies and bullets. We know the bomb's reward system is working, and we know my death system is working. I can take damage through collisions, and it can be a game over. So now we actually have playable gameplay. We have all of these systems coming together, right? Our enemy system, our player system, our movement system, our bullet system. Through collisions, we've tied them all together to create some really engaging and fun gameplay. I think in this state, Nova Strike is now playable. But we can probably make the user experience a little bit more enjoyable by adding some visual flair to the game. And I think in our next video, we'll add some visual systems that make the game really pop and engage the player. So I'll see you in that next video.